Hi everyone, I'm a chartered engineer with over a decade of experience working in the UK now. I passed my IStructE exam a few years ago, and today I'm just going to carry on going through the past paper 2023 February. Today's section 2C, which is the design calculations for the principal structural elements and the foundations. The way that I will be doing it is I am just going to start going through the calculations as much as I can in this tablet that I still need to get a better pen. Just explain how am I approaching each part and why am I selecting each element as the principal structural elements and what are the required calculations for each of them. Like what's the minimum calculations that you have to show. So that's it, let's go to it. So before we start, I'm just going to give some general advice that applies for section 2C, not only for this question, but for every time you respond to section 2C. Now, the first advice is regarding how to select the principal structural elements. So principal structural elements. Which ones are they? They generally are those that are singular to structure, not columns or beams or the floor itself. So they generally cantilevers. So whenever you have a cantilever, that would be one of them. Then there's if you have large spans. Yeah. The third one would be if you have any transfer structure. Definitely that's one of the principal ones. In this case, for this example, for this exam, the main structures that we have, or the primary structural elements that we got, are the steel truss, roof, okay? Then we got some hangers. That's very unique to this structure. So some steel hangers coming from the roof, and I would say because we don't have any other large ones, then a third one could be a typical one, which might be the steel bracing. And finally, is the foundations. Second main advice is it's always a good idea to have templates for the calculations. You might not have the exact same calculation, of course, because it will depend on the exam and the conditions, but it's always to have a good idea because you use them as a guidance in the exam. Third, as I said before, foundations always have to be calculated. In the exam, actually, in the question 2C, it says all the principal structural elements, including the foundations. So foundations, if you miss it, it might be a cause of failure. So make sure you always include the foundations in the calculations. Now, the fourth, even though you're going to do the design for them, for the regular beams and columns, you need to make sure you use a span to depth ratio. You at least size them, but it says right, because of time constraint, then we're going to use a span depth ratio, and this is a typical size that will be for the columns and for the beams. And fifth is, I suggest do not write intermediate units. So you'll see when I start doing calculations, only the initial units, and then when you do the calculations, just the numbers, and then in the end, what's the final units. You do the calculations, or you work out what will be the final units, of course, but you don't write them because they just take time of your exam. Now, okay, now that we got those 5 main advices, let's start with the actual calculations. So our structure is something like this. Yep. It's going to have some shallow foundations. The vertical bracing. And then, it's not to scale clearly here, but this is more or less what we got. You got your steel truss at the top, and you got some hangers here. Steel truss is another of the main elements. Let's put it in blue. The other element we're going to be designing is the bracing, which is normally simple, but it's considered main in this one, and the foundations. So those are the 4 elements that we're going to go through. Now, the layout of your calculations normally start with the load takedown. We start with the dead load, and we start dividing by story. Just doing here, level 1, level 2, level 3, and then we go level 4. And in plan view, well, you can see there in the drawing what it looks like. We got the conference hall, which we're looking at it, this part here, and the lower roof here, lower roof. Okay, so if we start with the dead load, level 1, we're going to have a ground bearing slab. So it's the ground bearing slab. And take 200 millimeters thick. Okay, so that means that our ground bearing slab is going to be 25 kilonewtons square meter density, it's cube meters density of the slab, and that gives us 5 kilonewtons square meter. Then we got the finishes. And services. Let's take 0.25. Oh, let's go to this. 0.25. Okay. Level 2. Level 2, we got the self weight. Which is going to be part the slab, and take 150 millimeters thick metal deck composite slab. The weight of them seems to be about 3.5 kilonewtons square meters. Okay, and that's just taken from a typical data sheet of a metal deck composite slab. And then you got the steel. And steel, let's say, typically take half a kilonewton square meter. Okay. And in addition to the self weight, we also got the finishes and services. Take a quarter of a. Now, where are these values coming from? Because one question that I had when I was studying for the exam is like, how detailed do I have to be in my calculations? And the answer is not really so detailed. You just have to show that you know what you're doing. Okay, and so when you come to you can take, and you don't have to prove why I'm taking the steel is 0.5. It's just that's a normal way. Those values are normally shown in in for example, the pocketbook, the structural engineer pocketbook shows this value. Take the 0.5 kilonewton square meters or 0.25 for finishes and services. So you can, so long as they are reasonable values, then you can just say that you're taking those values for this example. The same is for the wind. You'll see when I do the wind calculations. So you don't really have to go into the detailed part of the calculation explaining where all those values are coming from. So long as you show that you know what you're doing and they are reasonable values, then that should be fine. Now, where do you show that you know what you're doing? That's what we're going to show in here. And one good example will be when I do the calculation for the truss. I just need to show that I understand how the truss works and what are the minimum requirements, the calculations for them. But these values, like why did I take 150 for the slab thickness? All right, then I just say this is a typical slab thickness for a span of, and whatever my span is, I think is about 6 meters or 7 meters. So I can take that one, and then I don't have to prove that one because it's not the principal or primary structural element. Okay, now this one that I just did is for level 2 to 4. So if we come back, all those dead loads applies to here, and all this area. Okay, and we got our load in kilonewtons meter square. So now, remind me later. Now we got to, what else have we got? The cladding. That we know that they want to be stone, and normally stone brick, let's say take, I think it's a conservative value, but let's take 21 kilonewtons cubic meters, and it'll be single leaf. Assume single leaf 100 millimeters thick. So over the facade area, it'll be cladding with weight 21 times 0.1 is 2.1 kilonewtons square meter. Oh, I keep coming back to this. Okay, now we got the roof. This is dead low so far. Okay, so roof, we go lightweight, roof, and purlins. I'm going to get a better pen because it just, yeah, I have to write so big. This one now. For this one, I'm just going to take 1 kilonewton square meter. Again, this is also a recommendation that is normally shown in, and it might not be that exact value, but it's very close to it in the structural engineering pocketbook. Now we go to the live load. So we got all our dead load here in the load takedown, and now we go to live load. Live load, again, I'll try to make you more organized now. Level 1, if we go to the question, it shows us that level 1 live load is 7.5 kilonewton square meter, and the level 2 and 3 is 5 kilonewton square meter. For level 4 is divided in 2, and now if we come back, it's because it says lower roof and conference hall. So our live load around here, let's use a different color because we already used this one, here is 5, and our live load on the actual, oh wait, no, on the lower roof is 1.5, and in the conference hall is 5. Okay, right, my bad. misread that. So the lower roof, if we go to the plan view, and let's see if I can show the actual drawings from the question. Then you got the lower roof in this area is, what was the value? 1.5. And the conference also basically over this area here, but in plan is over this area. And in purple, I'm going to show over the conference hall, which is this area, the live load is 5. Okay, so our live load here is actually 5. Okay. And then finally, oh, let me just come back to here. So yeah, my live load, level 4, so lower roof is 1.5 kilonewton square meter, so 5, and level 4 conference hall, 5 kilonewton square meter. Okay, and then we got the roof. And the roof, the live load is 0.6, just for maintenance access. Okay, now once you have them all, then the best thing, or what I used to do, is create a table. And in that table, I'm just going to include the level. Okay, dead load, live load, and then I put my total in here. It just helped me so much afterwards to know exactly what values I am using. So for level 1, come back. For dead load, we got 5 and 0.25. Right, so it's 5.25. 5.25. And our live load at level 1, 7.5. 7.5. Right, because of this pen being so big, I probably is going to put the total, the total over here, right? So let's just use this one. Let's make this table slightly bigger. So dead load 5.25 and live load, what did we say, 7.5, right? No, again, right, 2, actually it's 2 to 3. The dead load, live load was 5, so we go here, 5, and our dead load took where we go. It's a bit messy, very messy. Make sure you don't make it like this messy in the exam. Very organized and tidy. I'll show in the responded exams how, at least how organized I would make it. If you can make it more organized and nicer and tidier, then better. Okay, so 3.5. We got as a dead load, that was the weight of the slab, and then we got the steel itself is 0.5, and then we got the finishes and services, so 3.5, 0.5, so it would be 425. So 425. Then level 4. Level, I think I made a mistake here. Put this as a 4. This should be actually level 3. Oh, no, because the dead load is the same. No, sorry, my bad. It is correct here, level 4. So the dead load in level 4 would be the same. 4.25, and we actually have level 4 lower roof and level 4 conference hall. Okay, and my dead load is the same because the floor is going to be the same over here and over here. So then we come back to the live load. Live load 1.5 and 5. So 1.5, 5. And then the roof. On the roof, we got a dead load, well, live load 0.6 and a dead load 1 kilonewton square meter. Okay, and basically I'm just going to go now a new table, but with the total ones, because I don't have space here. So, and I'm going to put the SLS and the ULS. Okay. Now level. And we go first level, and I'm going to write that for SLS combination, it's going to be 1 times the permanent load plus 1 times the variable load, and the ULS combination is going to be 1.35 with permanent load plus 1.5 my variable load. Okay, so come back, we do our calculations, is 525 times 1 and 1 times 5. Let's see. That's 12.75 kilonewtons square meter. Again, for now we're ignoring the cladding, so we probably need to make a note. I'll make a note later. Cladding load not consider, and explain the because. The most loaded, or the highest loaded trusses and other elements, except the hangers. The hangers will be intermediate elements. Those are the perimeter. If we got our trusses placed this way, right, and supports here, and here, for example, those at the perimeter will only be loaded halfway. It's true there will be also the masonry, but the spacing is very high. I think it was about 14 meters. So the intermediate ones will have a bigger loaded area. So therefore, I expect that the load in those middle ones is going to be higher. But well, so long as you explain and it makes sense what you're explaining, then it's fine. So long as you don't have to do all the calculations, just the primary ones. Now, and for the worst case scenario, let's see if we carry on. The ULS, it was 1.35 times 5.25 plus 1.5 times 7.5 was the live load. Yes. And that gave us 18.34. Not again. You need to improve in this. Huh? now level 2 and 3. Level 2 and 3, we got 4.25, I think. Yes. Plus 5 would be 925. I'm actually going to say that these are kilonewtons meter square, so I don't have to write them again and again. Kilonewtons square meter, sorry, square meter. And then is 1.35 times 4.25 plus 1.5 times 5. It's 13 point. Yeah, 13.24. Now go level 4, lower roof. And that would be 1 times 4.25 plus 1.5 is 5.75. On the ULS, $7.98. And then our conference hall. Okay, so is 4.25 plus 5, that's 9.25. And then the ULS is 13.24. And finally the roof, which was, I think it was 1 and 0.6. Yes, so 1.6 here and 2.25. Good. So then later, right, I got this, we'll explain about wind load. Well, it says if we go back to the question, it says that the mean hourly wind is 20 meters per second. That's average. So based on that, I'll say that my design wind load is going to be 1.2 kilonewton square meters as design wind load for normal site location. Okay. That's fine. Now we're going to start designing our first primary structural element, which is going to be the truss.